Hello everyone, welcome to my channel, your integration buddy. In today's video, I will introduce you to the one of the leading integration platform, MuleSoft, and we will cover some of the key topics that you need to understand in order to prepare for MuleSoft Integration Associate certification. Towards the end of this video, I will share the link to the official documentation provided by MuleSoft for this certification, as well as share the link of practice test with you to prepare yourself for this certification. After watching the video, please make sure to subscribe to my channel so that you don't miss any interesting upcoming integration videos from me. So without wasting much time, let's get started. Let's get started with the understanding of cloud computing and the different types of cloud computing environments we have. So cloud computing, as you might be aware, it is the method of delivering the IT services over internet. Here, the users can access the computing resources like servers, storage, and applications through the internet instead of owning and managing these resources themselves. Obviously, cloud computing offers several benefits, that's why it has become so popular nowadays. Main benefits include cost savings. Here we don't need to maintain or purchase expensive hardware and software. Instead, we just pay for the resources what we use. Then cloud computing offers scalability, which allows the organizations to quickly scale up or down the amount of computing resources they need as per their change in demand. Then cloud computing offers flexibility. It allows the organizations to access and use the computing resources from anywhere with an internet connection. Lastly, cloud computing offers high levels of uptime and disaster recovery options, making it easier for the companies to ensure the availability and reliability of their computing resources. So that's pretty much about the basics of cloud computing. Now coming on to the types of cloud computing environments we have. So generally we have only four types of cloud computing environments. First one is the private cloud, which refers to the cloud computing environment which is dedicated to a single organization. Here that organization is solely responsible for managing those cloud resources. The private clouds are typically set up within the organization's data center, and the private clouds provide organizations more control over security, privacy, as well as allow them to meet specific regulatory requirements. Coming on to next is the public cloud, which most of us are aware. It is the cloud computing environment which is owned and operated by a third party service provider and is made available to the public over internet. It is the most cost-effective option for organizations. Popular public cloud providers include AWS, Microsoft Azure, and Google Cloud Platform. Next is the hybrid cloud. As the name indicates, it is a combination of both private and public clouds. Here, the organizations adopt a hybrid cloud strategy and use the public cloud for less sensitive workloads such as web facing applications and the private cloud for more sensitive workloads like databases and enterprise applications. Lastly, we have the multi-cloud, which refers to environment where the companies use multiple cloud services from different cloud providers. Here, it enables the companies to take advantage of the best services offered by multiple providers and reduce the dependency on a single cloud provider. However, it presents a challenge in terms of integration and management, as each cloud service may have different requirements and capabilities. So that's pretty much about the cloud computing and different types of cloud. Moving on to the next topic, we have cloud computing models. So typically we have three types of cloud computing models. First one is the infrastructure as a service. As the name indicates, here the cloud provider offers virtualized computing resources such as servers, storage, and networking over the internet. The customers can access these resources and use them in their own applications and services. Examples of infrastructure as a service providers include AWS, Microsoft Azure, and Google Cloud Platform. Then comes the platform as a service. In this cloud computing model, the cloud provider offers a platform for customers to develop, run, and manage their own applications without having to worry about the underlying infrastructure. The platform as a service typically includes the tools and services for application development, deployment, and management. Examples of platform as a service providers include Google App Engine and Microsoft Azure App Service. Lastly, we have the software as a service. In this cloud computing model, the cloud provider offers a complete software application that customers can access and use over the internet. So they don't have to worry about the underlying infrastructure or the installation and maintenance of the software. Software as a service applications are typically subscription based services. Examples include Salesforce, Google Drive, Microsoft Office 365. That's pretty much about the cloud computing models. So now we know the basics of cloud computing, different types of cloud computing environments, different types of cloud computing models. Now it's the time to introduce you to the one of the leading integration platforms, MuleSoft. So what is MuleSoft? MuleSoft is a complete integration platform as a service which provides a full range of tools and services for building, deploying, and managing integrations between various systems and applications. MuleSoft uses a modern API first approach, which means the creation and management of APIs is at the center of the platform. The API first approach helps to ensure that the APIs are well designed, secured, and easy to use. MuleSoft comes with a rich set of pre-built connectors, which are called Anypoint connectors. So they are used for connecting to popular enterprise systems like Salesforce, SAP, Oracle, to name a few. They can also be used to connect to cloud-based services like Amazon S3 or Google Drive. MuleSoft Runtime provides a scalable and reliable execution environment for running integrations and APIs. It supports various types of data and protocols including REST, SOAP, HTTP, JMS, and many others. Last but not the least, MuleSoft comes with a range of management and administration tools for monitoring and managing integrations, as well as features for managing API access and security. The MuleSoft environment is designed to be reliable and scalable, making it suitable for large companies and mission critical use cases. So that's pretty much about introduction to MuleSoft. In this section, let's focus on the API-led connectivity approach. So API-led connectivity approach is for designing and developing APIs that focus on creating reusable or modular pieces of functionality which can then be combined to form end-to-end business capabilities. API-led connectivity has three main components: experience APIs, process APIs, and system APIs. Experience APIs are designed to enable the delivery of user-facing experiences. They provide a way for applications to access data and functionality through a simple and consistent interface, thereby abstracting away the underlying systems of record. This allows the companies to quickly and easily change the front end of their applications without having to make changes to their backend systems. Next comes the process APIs. So process APIs are used to manage and orchestrate business processes. They provide a way for different systems to communicate and collaborate to accomplish a specific business outcome. Lastly, we have the system APIs, which provide access to systems of record, such as databases or legacy systems. So to summarize, API-led connectivity emphasizes the use of APIs to connect different systems and enable the delivery of end-to-end business capabilities. The different types of APIs serve different purposes and are designed to work together to support this goal. So that's pretty much about the API-led connectivity. In this section, let's learn about the REST APIs, which are commonly used in the API-led connectivity approach. REST stands for Representational State Transfer. It's a set of architectural principles for building web-based APIs. Here are some of the key characteristics of REST APIs. First one is the client-server architecture. REST APIs follow a client-server architecture, where the client makes requests to the server and the server returns responses. Then REST APIs follow the architecture of statelessness. The REST APIs are stateless, meaning that each request from the client to the server contains all the information necessary to complete the request. This allows for greater scalability, as the server does not need to maintain any client state between the requests. Then comes the concept of cacheability. Here the REST APIs are designed to be cacheable, meaning the responses from APIs can be stored by intermediate caches to improve the performance. It also helps to reduce network latency and reduce the load on the server. REST APIs follow a layered system architecture, where different layers of system can be isolated and updated independently. This allows for greater flexibility and scalability, as changes can be made to one layer without affecting the others. Last but not the least, REST APIs have a uniform interface, meaning they use a consistent set of operations such as get, post, put, or delete to interact with the resources. That's pretty much about REST APIs. Since the REST APIs use the HTTP protocol, in this section we will learn about the common HTTP codes and the operations. Coming on to the codes first, the codes which are starting with 1 indicates an information. The code starting with 2 indicates a success or an OK response. The code starting with 3 indicates a redirection of the URL. The code starting with 4 indicates a client-side error. And finally, the code starting with 5 indicates a server-side error. Coming on to the common HTTP operations, we have GET operation, which is used to retrieve a resource information. We have POST operation, which is used for creating a new resource. We have delete operation, which is used to delete a particular resource. We have put operation, which is used to update the resource, and in case the resource is not available, it can be create a new resource. Lastly, we have a patch operation, which is used for the partial update of the resource. That's pretty much about the common HTTP codes and operations. In this section, we will learn about the API lifecycle in MuleSoft. The API lifecycle refers to the stages an API goes through from its design and development to its deployment and management. The lifecycle can be divided into various stages. It starts with a design stage. This stage involves defining the requirements and design of the API, including the endpoints, data structures, and security considerations. Next comes the development stage, which involves writing the code for the API, testing it, and preparing it for deployment. Next comes the deployment stage, which involves the deploying the API to a production environment and making it available to consumers. Last but not the least is the management stage, which involves monitoring and managing the API, including monitoring its usage, tracking performance, and making updates as needed. Each stage of the API lifecycle is supported by MuleSoft tools and technologies such as Anypoint Design Center for design, Anypoint Studio for development, Anypoint Platform for deployment and management. The goal of the API lifecycle is to ensure that the APIs are designed, developed, and deployed in a consistent and secured manner to meet the needs of both API consumers and the business. That's pretty much about the API lifecycle. In this section, we will learn about MuleSoft's Anypoint platform. MuleSoft's Anypoint platform is a unified platform for API-led connectivity that provides a complete solution for designing, building, managing, and deploying APIs and integrations. It consists of two main components, control plane and the runtime plane. The control plane is a centralized management component of Anypoint platform. It provides a single point of control for the API and integration assets of an organization. The control plane includes features such as API Designer, which is a visual interface for designing and documenting APIs, API Manager, which is a centralized repository for managing and publishing APIs, Exchange, a marketplace for discovering and sharing APIs, connectors, and templates, Access Management, a role-based access control system for managing users and permissions, Monitoring, a set of tools for monitoring the health and performance of APIs and integrations. The runtime plane is the component of the endpoint platform that handles the actual execution of APIs and integrations. It provides a highly scalable runtime environment for executing APIs and integrations. The runtime plane includes Mule Runtime, which is a lightweight, scalable runtime engine for executing APIs and integrations. And it also includes endpoint connectors, which are used for connecting to different systems. That's pretty much about the MuleSoft Anypoint platform. In this section, we will talk about the different MuleSoft deployment models. The first deployment model is on Cloud Hub. Here, the control plane and runtime plane both are hosted by MuleSoft. Then comes the standalone Mule runtime model, in which the control plane is hosted by MuleSoft and the runtime plane is hosted by the customer. Then comes the runtime fabric on VMs or bare metals. Here, the control plane is hosted by MuleSoft and runtime plane hosted by the customer. Then comes the runtime fabric on self-managed Kubernetes, where the control plane is hosted by MuleSoft and runtime plane is hosted by the customer. Last but not the least, we have the Anypoint Platform Private Cloud Edition, in which both the control plane as well as the runtime plane are hosted by the customer. That's pretty much about the MuleSoft deployment models. In this section, we will learn about the different scaling types. First one is the horizontal scaling. Horizontal scaling, which is also known as scale out, involves adding more resources such as servers, nodes to a system to handle an increase in workload or demand. This allows the system to handle more requests and maintain performance as the load increases. as it is depicted in the first diagram. Then comes the vertical scaling, in which more resources are added to a single node in a system to handle an increase in the workload. This approach can be less expensive than the horizontal scaling, but may be limited by the maximum resources available on a single node. This is depicted in the second diagram on this slide. Last but not the least, we have the diagonal scaling, in which more resources are added to the system in both horizontal and vertical dimensions, thereby combining the benefits of both horizontal and vertical scaling. Firstly, the resources are added in the vertical direction. Once the maximum limit is reached, then the resources are expanded in the horizontal direction. That's pretty much about the scaling types. In this section, we will learn about the Flex Gateway and Service Mesh. Flex Gateway and Service Mesh are two different technologies for managing network traffic in microservices-based architectures. Flex Gateway is a component of MuleSoft's Anypoint platform that provides API management capabilities for managing, securing, and analyzing API traffic. It allows to manage and secure APIs through features such as rate limiting, security policies, and analytics. Flex Gateway sits in front of your API and acts as a reverse proxy, thereby allowing you to control access to your API and manage traffic between your API and its consumers. Then we have Service Mesh, which on the other hand is a dedicated infrastructure layer for managing network traffic between microservices in a distributed system. Service Mesh provides features such as load balancing, traffic management, service discovery, and security. Service Mesh can help to address some of the challenges of microservices-based architectures, such as managing the communication between microservices, ensuring service availability and reliability, and maintaining security. To summarize, Flex Gateway and Service Mesh are two different technologies with different goals and functions. Flex Gateway provides API management capabilities, while Service Mesh provides network traffic management capabilities for microservices-based architectures. They can be used together to provide a comprehensive solution for managing API traffic in a microservices-based architecture. That's pretty much about Flex Gateway and Service Mesh. In this section, we will learn about the integration between CRM and ERP systems via MuleSoft. MuleSoft's Anypoint platform provides the tools and technologies needed to integrate CRM and ERP systems. The MuleSoft platform includes pre-built connectors for popular CRM and ERP systems such as Salesforce, Oracle, and SAP. It also includes a powerful integration engine for building custom integrations. In summary, integrating CRM and ERP systems with MuleSoft can provide the organizations with improved data quality, increased workflow efficiency, enhanced customer experience, and increased visibility and insight. The diagram on the screen illustrates the integration of CRM functions with the ERP functions via MuleSoft. That's pretty much about the CRM and ERP systems integration. So the last topic we have to cover is the MuleSoft Catalyst. As per MuleSoft Catalyst is a unique operating model that provides the best practices, online tutorials, templates, and resources for MuleSoft customers and partners at all levels of experience. MuleSoft Catalyst has three pillars. First one is the organization enablement. Here, the MuleSoft Catalyst provides training, certification, and support to help organizations build a skilled and capable API and integration team. This includes technical and non-technical training, hands-on experience with MuleSoft technologies, and access to expert support. Second pillar is the technology delivery. Here, the MuleSoft Catalyst provides a set of best practices, tools, and technologies to help organizations design, develop, deploy the APIs and integrations quickly and effectively. The third pillar is the business outcomes. Here, the MuleSoft Catalyst helps organizations realize business outcomes through API-led connectivity. That's pretty much about MuleSoft Catalyst. So we have come to the end of this tutorial. Please make sure that along with this tutorial, you also go through the official material that is provided by MuleSoft to prepare for the MuleSoft Integration Associate certification. The link to the official material is shown on the screen. After going through this material, kindly attempt the practice exam on training.mulesoft.com website. This will give you good confidence to prepare for the exam. The MuleSoft Integration Associate exam consists of 40 questions and the time limit is 90 minutes. It's a proctored and a closed book exam. That's pretty much from my side in this tutorial. Thank you and all the best.